Hey, welcome aboard, folks. How you doing there, Charlie? We all having a good time? Ready for some experiments today? Looks like I got everything all set up. Here we go. We got two stir plates going here. Hello there, very cools. Welcome aboard. Let's start off with some acid-base experiments like we normally do, shall we? Get a little of, you can see my universal indicator I'm picking up here. Hello there, Charlie. pH 7. You see it's green. And I'm adding this to tap water. So this is water from my tap, and you can see the water from my tap is neutral to slightly basic. What's going on, Christopher? We got some experiments we're doing today. Ha! 847, what's happening? What is happening? Right now, I'm just adding some universal indicator to both of these flasks. All right, you got it, Very Cools. We're going to add some base first. Very Cools has a request to add some base first, which is what we're going to do. Here we go, a little more. I think I'm going to go just a bit more in each. Get a little bit more color. There we go, baby. What's going on, Just Richie? Welcome aboard. We're just getting set up, just getting started. All right. Base first, here we go. I'll do 1 drop of base to each. Here we go. 1 drop of base over here on the left. 1 drop of base on the right. We're going immediate pH 10, huh? Hello, Amal. Welcome aboard. Let me get this light off here. Make it look a little nicer. Carbonic acid as my acid. We could do that. Very cool. So let's do that. I'm gonna add some carbonic acid. This is a very simple experiment to do. Here we go. Gotta get the light on here for a second so I can actually pull this off. What flask am I going to use? I'll use this flask here. We'll use this flask. All right, we're going to add some carbonic acid as my acid. I don't want to put that too far back. It'll fall off. There we go. All right. So who's it? The Very Cools is the one who's asked for this. I got to find a funnel because I don't want everything going everywhere. All right. I'm going to pour a little bit of this in there. We know this is a high pH, right? Like a pH. I'm still getting stuff all over the place. Little bit of mess. There we go. Well, we know this is high pH, yeah? pH 10. Here, let me show you the acid-base indicator chart. Okay, now I'm going to add some carbonic acid. And the way that I'm going to do that is very simple. I'm just going to exhale into this through a straw. And I'll be putting carbon dioxide into the mixture here. You know, I mean, now, a lot of people think that what we exhale is 100% carbon dioxide, but that's not true. Mostly what we exhale is nitrogen gas, just like what's in the air. Some of it's oxygen. So in regular air, 21% of the air is O2 gas or oxygen gas. And then when we inhale that, we use up some of that oxygen. And what we exhale has only 16% oxygen, roughly speaking. What we inhale has very little carbon dioxide, but what we exhale has 4% carbon dioxide. So I'm going to be exhaling 4% carbon dioxide into this, just through my breath. Here we go. I can't see the comments while I'm doing this. I'm hoping it's going to stay in focus. Here we go. Oh, I'm getting out of breath. Oh, Looks like we got down a little bit lower than pH 7. Let me keep going. I don't know if I'm going to get much further. But yeah, we got it around pH 6, yeah? So yeah, that's a bong. It's not a bong. It's just chemistry, huh? There's a little chemistry going on there. Blew some, carbon dioxide into the solution, and that made it go acidic, right? It's going to, carbon dioxide is acidic. Okay, let's add some hydrochloric acid. So we're doing all kinds of body acids here today. We did carbonic acid from our exhaled breath, which is just carbon dioxide. And then we're going to add some hydrochloric acid, which is the same acid that's found in your stomach. Let's do atomic number game, but hard mode. You only have one guess and can't go through the periodic table. Well, I'm not going to be able to do that. All right, here we go. Let's add some drops of hydrochloric acid over here on the left. Let's go 2 drops. 2 drops on the right. We're going to have to add a little more, I think, to get some action. So I'm going to add a little more to both sides. Very beautiful. A little more. Left, right. And we'll chase it with some base on both sides. So base, sodium hydroxide, 1 drop over here on the left, 1 drop over here on the right. Yeah, the base is a bit more concentrated than the acid that I'm adding. Thank you there, Michael. Let's add 1, 2, 3, 4 drops of acid on the left, 1, 2, 3, 4 drops of acid on the right. The acid that I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. It's just that what I'm adding is a lot more concentrated. Okay, I'm going to keep adding acid here. A couple drops here on the left. A couple drops on the right. There we go. I'm going to add in this stuff here. Okay, now we're going to add drops of sodium hydroxide. By the way, here are the different pH values that you'll see. You know, the different colors, different pH values. If you see green, it's neutral. Red, orange, or yellow is acidic. Blue and violet is base. Here we go. Let's add some drops of sodium hydroxide. 1 drop over here on the left. Let's go like 2 drops, maybe 3. 1, 2, 3. I'm going to try to get the rainbow. So it looks like 3 drops might be too much. So I'm going to go 2 drops over here on the left. Excuse me, on the right. 1, 2. Let's see. There we go, man. We got a rainbow flash, baby. Come on now. That lasted a good long time. That was beautiful. Oh, nice. Here we go. Let's add some drops over here. 1, 2, 3. Yeah, you're right, very cool. I messed up on that. I meant neodymium. Here we go. 1, 2. Man, I got to add a bunch of acid over here on the left to get that acidified. I'm going to add, 1, 2, 3 drops over here on the right. Let's keep going. 1, 2, 3 drops on the left. 1, 2, 3 drops on the right. So I've added hydrochloric acid, the same acid that's found in your stomach. And you can see the pH is dropped. Well, you can see the color is what you're seeing. This looks like an orange color. This is like an orange yellow. So then on the left, our pH is maybe a pH of 4. And over here on the right, it's maybe 4, 4.5. So I'm going to keep adding acid to try to get that a nice cherry red color. I'm going to go 2 more drops of acid over here on the left. 1, 2. 2 drops over here. Let's go 3 on the right. That should go to a more red color on both sides. Now we got like pH 3 on both sides. Now I'm going to add some sodium hydroxide base to neutralize that acid. We should see all sorts of colors as the reaction takes place. Here we go. Let's go like 2 drops over here on the left. 2 drops of sodium hydroxide base. We'll see the color shift to more blues and reds. I think we got a little rainbow flash. Isn't that beautiful? Let's go 2 drops over here on the right. 1, 2. Very cool. Oh, very cool. Why did I skip that? It just the music didn't, there wasn't enough music to include all the elements in the lyrics. That's why. Here we go. Let's go like 2 drops over here on the right. 1, 2, 3. That's 3 drops of hydrochloric acid on the right. Let's go 2 more. 1, 2. Hydrochloric acid is the same acid that's found in your stomach. Planet, not North. Or excuse me, planet, not Earth. This is the reaction that's going on. So I'm going to write this down really quickly. Give me a second here. Well, here we go. All right, let me get some action going here before I answer this. Here we go. Let's do hydrochloric acid over here on the left. 1, 2, 3, 4 drops. I'm going to do 2 drops of sodium hydroxide over here on the right. See if you get a little rainbow action while I'm writing out the chemical reaction that's going on. That's gorgeous. Come on, man. Look at that beautiful rainbow tornado. HCl. That's still going, man. Plus sodium hydroxide. So here's the, I look like an opal birthstone. It looks like fake, but hey, Han, here. Let's add a little base over here on the left. 1, 2, there we go. All right, so here's the reaction that's going on. I am either adding hydrochloric acid, which we symbolize as HCl. It's a hydrogen atom attached to a chlorine atom, making HCl. And we're going to react that with sodium hydroxide. Sodium's Latin name is natrium. That's why it has that Na. And this OH is a hydroxide. Let's get some action going here. Let's go some acid over here on the left, like 5 drops. And then we're going to go 5 drops on the left. Get that good and acidified. The indicator being used, planet, not Earth, is universal indicator. Now, what's formed in the reaction... curses. There we go. What's formed in the reaction is water, and then the chloride ion from the hydrochloric acid, and the sodium ion from the sodium hydroxide forms sodium chloride. So you're getting salt water is what you're making. So here I'm going to add some, let's go sodium hydroxide over here on the right. 1, 2 drops. You got it, Wordleneck. Let's add some acid over here on the left. 1, 2, 3, 4, 5 drops. Isn't that something there, estrogen? I agree. It's really cool. That's right, James Dillon. Sodium hydroxide is better known as lye. But yeah, what's making the colors, estrogen, is that I have added an acid-base indicator to both flasks. And the acid-base indicators, they simply, change color depending upon how acidic or basic something is. So as I add more acid, here's your pH scale. Sure, we can do that, very cool. As I'm going to turn the stir bar off on this side over here on the left. As I add more acid, as you get more acid than base, you start to enter the low pH zone. So that's pH 6 through pH 3. The more acidic it gets, the more red it gets. If the acid and base are perfectly balanced, we'll be here at green and neutral. And if there's more base than acid, you'll end the blue and violet zone. The more violet means a lot more base than acid. The indicator I'm using, estrogen, is called universal indicator. Here we go. Over here on the left, I'm going to start adding some drops of sodium hydroxide. So that, if I add drops of sodium hydroxide, that should neutralize the acid, and we're going to head this way. Here we go. Let's add, let's go like 2 drops of base. 1. You can see the purple cloud kind of fall in there where the base hits the indicator. Now, these two are going to, the acid and the base are going to react with each other. Cool there, James. Okay, over here on the left, let's go like, 2 drops of base. Let's see. 1, 2. Let's see if we get a rainbow flash. We're trying to get a slow motion rainbow over here. Look at that. Come on, baby. I've got the rainbow going like crazy today. Thanks there, Willie. We are definitely doing well. What's going on, Caleb? Thank you there, Chimp Dog. Hello there, Momon. Hey, you can see that over on the left. Look at that. We got like a static rainbow on the left, man. Sure enough there, estrogen. They are organic molecules that are changing color, but it definitely is acid-base chemistry that's occurring. Hey, thanks there, Willie. I appreciate that. I'm adding acid over here to the right. Thanks there, Xana. Thank you there, Churro. Thank you there, Moman. I appreciate that. Thank you there, Alcatito. And I apologize if I'm saying names wrong. It's going to happen. You feel free to correct me. Yeah, we might switch to a different experiment, but I'm telling you what, I'm kind of liking this over here. Look at that. Isn't that beautiful, that sort of static rainbow? We're making a pH gradient over there. So we got a low pH 3 at the top, and we got a high pH 10 at the bottom. Litmus test, Arvas. Kind of right. All right, let's do 2 drops of sodium hydroxide over here on the right. Come on, baby. Come on, baby. 1, 2. Thank you there, don't hit me. I agree, Willie. There is something nice about that. Look at that. Like that. Come on, man. That was cool. That dynamic rainbow. Hey, thanks, Sarah Pang. I appreciate that. I appreciate this. My live stream's not for everybody, but for those that are enjoying it, thanks for hanging out. There's something going on here on the one on the right that I want to point out. It's kind of fun. Chimp Dog, come on, man. Chimp Dog just sent me $2.99. Oh, that's much appreciated. It's not letting me like it. What the heck? What the heck? Thank you there, Chimp. I appreciate the love. Appreciate it very much. Why did the vertical column remain on the left after so much time? So BLR, what's going on the left is, if you look over here, you see that? There's a stir bar that's going. Over here on the, excuse me, that's the right. Over here on the left, there's a stir bar in there, but I've stopped it. So if I turn that stir bar back on, we're gonna ruin that rainbow, which is fine if people want to do that. Wilton, thanks. Thanks for the correction. It is psychedelic, don't hit. Yes, Sasta, you can, it's like an artistic titration. Thank you there, Walker Squad. Yeah, we got a really nice pH pH gradient going over here. So let's look at this. I mean, it's just basically this, isn't it? Isn't that kind of cool? Like this tower is basically this. So we have a pH of 3 at the top, and then you can see it change to like an orange here. That's going to be pH 4 and 5. And then we got a big region where there's pH 6. And then just a little bit of pH 7, that's green. And then pH 8, a little bit of blue. And, most of it's pH 10. Can try and put the pipette far and inject into a specific level. That's a great idea, Enduro. Come on, man, let's do it. Enduro, I'm going to see if I can pull this off. Let me get a pipette. So Enduro's got a neat little comment to try. I think we can do this at the pH 6 level. So I'm going to get my, this is going to be a little tough to pull off. We're going to give it a shot, all right? So I'm going to get some of my sodium hydroxide base, okay? And I'm going to get it into my large pipette here. What a great suggestion. Yes, it just does turn this into water. Okay, I'm just going to get a little bit. This stuff's kind of nasty. I don't want to drop it anyway. So I got some strong base, sodium hydroxide base in here. Okay, and I'm going to put it down in here. Let's just go right there. You can already see it dripping out, man. Come on, man. Look at that. You can totally see it dripping out. Yeah, I'm going to add it. I'm squeezing it just a bit. You can totally see the base coming out. There it goes, baby. And it goes. That's going to turn everything basic. It's like a cloudiness overcoming the rainbow. Let's go ahead and stir this up over here on the left. We messed it up. Yes, I am, Pang. Thank you there, Wilton. Thanks, Chimp Dog. Yeah, coffee. Probably not going to happen here in my basement. I don't have the appropriate PPE. It was satisfying. Let's add some acid over here. Acidify this over here on the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 drops. Let's see if that's enough to neutralize the base. Thank you there, Enduro. I'm going to try Very Cools. Wow, I added 10 drops of 20% hydrochloric acid, and we're still not there. So let's keep going. I'm going to add another drop. There's the 11th drop. So we're at here. I'm going to look at this over here. Here's our pH scale over here. Let's get some light on that so you can see it just a little bit better. There we go. So we're still at pH 10. I'm going to add another drop of hydrochloric acid over here on the left. Nothing. Let's add another one. Thank you there, Arvis. There's another drop. Indeed, Arvis. Let's add another drop. Boom. Boy, that is really basic. That's because I added a whole... Here, let's go like 10 drops. 1, 2, 3, 4. There's 5 drops. My goodness gracious. Still, I'll go 5 more. 1, 2, 3, 4, 5. I think we're getting it there. I can see some red surviving. I think we've shifted it. We've shifted it from like a pH 10 down maybe a pH 8. Estrogen, it cost me about 40 bucks. Let's add another drop of hydrochloric acid. So we went from pH 8 to pH 7, maybe pH 6. Let's add another drop. Now we're moving. We're definitely at pH 6. I'm going to add 3 drops here. 1, 2, 3. Looks like we've got down to pH 4 or 5. I agree, Enduro. And it's true, Chimp Dog. We're about pH 5. Let's go 2 more drops. 1, 2. We're at like pH 4. I'm going to add 1 more drop. Oh, that's a nice cherry red. So, yeah, we added a bunch of acid. The acid I added is hydrochloric acid. See, this is the reaction that happens. Hydrochloric acid reacts with sodium hydroxide, and you get water and you get salt. It neutralizes it. And if you have an excess of acid, then, of course, it's going to be acidic. Now I'm going to add some sodium hydroxide base to this solution over here, which is acidic at pH 3. And watch what happens as I start to add the base. Here we go. I'll add 1 drop of base. In it goes. Let's go 2 drops. 1, 2. You're going to see all sorts of colors. You know, because the reaction takes a little bit of time. Oh, man, I overshot. Look at that. Man, we went from pH 3 to like pH 8 with 2 drops. Look at that. So, yeah, there's an excess of base already. So I'm going to try to acidify this. Let's add a drop of acid. We're going to go back in the other direction now. Yeah, the reaction happening in your body when you take an Alka-Seltzer is this. Your hydrochloric acid in your stomach, HCl, it takes 2 of those. Well, this is a Tums. This isn't an Alka-Seltzer, but this would be a Tums. So you got 2 acid molecules react with the calcium carbonate in the Tums, and what happens is you get a salt called calcium chloride, and you get carbon dioxide, and you get water. So that's what happens with a Tums. You get calcium chloride, and the acid gets neutralized. You get carbon dioxide and water. Now this stuff, this is why you burp a little bit after, a little bit after taking a Tums, you'll usually burp. That's from the formation of the carbon dioxide that builds up in your stomach. I don't know if you notice that, but I tend to notice. Yeah, a little bit later. I got to get rid of the CO2 gas that's formed. Thank you there, operator. Appreciate that. Let's add a little more acid here to this flask on the left. Boom, 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 boom. 5. And let's add 2 drops of sodium hydroxide on this side over here. Thanks there, Martin. Here we go. 1, 2 drops of base. Give me the rainbow, baby. Come on now. I think I'm going to need 1 more drop. Look at that. We got a little rainbow flash. Isn't that cool? That's very cool when that happens. Yeah, that's why, Chimp Dog. That's exactly why. Ah, that's cool. Tanisk, that's great. Tanisk gave a test on equilibrium today, and this thing kept flashing in their mind. That's awesome. I have 300 views. Cool, Pang. Very cool. Thanks there. Subramania. I love the name, man. You guys are challenging me with these names. We make a pH 4. Let's try here. I'm going to stop right there, see what happens. Any chemical engineers in the house? Ashish wants to know. Yeah, science. Come on, private sector. The indicator I'm using, Sajayan, is a universal indicator. Can I touch it safely? Ryan, yeah, you could, but it's not recommended. Let's just put it that way. Very cool, man. Faraday, thank you. If it spun faster, it would ruin the colors. Here, let's watch. Let's turn this off over here. We're going to turn this stir bar off over here on the left. And now I'm going to add some sodium hydroxide, which will increase the pH. By the way, someone was asking to get it to pH 4. I think I've done it over here on the right. Let's add 2 drops of sodium hydroxide base and watch what happens to the static flask over here on the left. 1, 2. You can see that violet color. See that violet color grow in. That's from the base, and then the acid and the base will react with one another, and these, the colors will kind of come to the center, and you'll see a bunch of the different colors along the way. Look at that. I mean, you can already see a bunch of different colors in there. It goes fast, oh dog. All right, now over here on the right, let's go ahead and add some acid to acidify this. Look at that gorgeousness over there on the left, man. I am loving that. Okay. Hello there, Twitch. Here we go. I'm going to add some acid to this flask over here. It looks like the base is winning, so let's just add a few squirts of acid right around the top like that. Let's see what happens. See if we get some red in there. Hello there, ADRS. Hello there, Munninfin. Okay, let's add 2 drops of base over here on the left so we can get the rainbow. Come on, baby. 1, 2. Let's go. Let's go. Come on, give me the dynamic rainbow. There it is. Come on now. That is so beautiful. I love that. Absolutely love that. Hey, let's do the separation experiment. We've been doing this long enough. We'll do the separation experiment, okay? I'll leave this one doing here. I'll add another drop of base over here on the right. I think so, Chimp Dog. Another drop of base over there just to watch that going. We're going to do the separation experiment. I hope it works. So here's what I'm going to do. I'm going to take this bottle that's got a fluid in it. Let's fill it all the way to the top, shall we? We're going to fill this bottle all the way to the top. Okay? All right. So let me get my funnel here. And I'm going to add some more liquid so I can fill this all the way to the top. Here we go. In it goes. Don't give it away if you've seen this before. Okay, we got that in. I've filled my flask to the top. And now I'm going to add, what am I going to add? I'm going to add some purple food dye, all right? Let's add a couple drops of purple. I don't have any fluorescein. Here we go. Purple food dye, 1 drop. Look at that gorgeousness. Just 1 drop of purple food dye. It's like you got a fractal pattern going on in there, isn't it? It's like Halloween, man. That looks awesome. Man, does that look beautiful. Let's add another drop. I mean, look at those tendrils. Look at that. I don't know. I find little phenomena just beautiful. Okay, let's add another drop here. Another drop. Boom. All right, 2 drops. Ooh, look at that. What the heck is going on? It makes me wonder if there's like some kind of heat convection going on in there. What if I added bromine? We're not doing this. Large, I think we're okay. All right, let's shake this thing up, huh? Look at our pH gradient over there on the left now, too. We got lots of color going on here. It's just beautiful. Thank you there, Frank. Let's shake this baby up. Let's shake this baby up and see what happens, okay? I don't know what you mean by an Emboudour moonbow. I apologize there, Shane. So yeah, it's probably expected. We just made a purple solution. Hey, thank you there, Ben. I appreciate that. Liquid dynamics and viscosity. Tubular, you could probably teach me something a little bit about what's going on in there. Okay. Sorry, the comments are coming through a little fast and rough. Or fast and furious. I can't quite get to them all. I'm doing the best that I can. All right, now what we're going to do is I'm now going to this flask over here, or this bottle, I should say, over here on the right. Hey, thanks there, Ben. I appreciate it. I am going to add some salt. All right, that's all this is, just table salt. All right, and I'm just going to add this to this bottle over here on this side. We're going to shake it up and watch what happens. Why did it stop in the middle, asked Estrogen? Come on. That's a great observation. I'm not going to answer you, but that's a really important observation, Estrogen. Here we go. And why is it bubbling? All these are good stuff, man. Great observations. So I'm going to go ahead and pour this salt in. In it goes. Oh, you guys are going to love this. I'm telling you, you're going to love this. You just can't wait to see this. Look at that gorgeousness on the left over there. Tommy Twitch asks, I have to see a Now Red's video where he turns gloves into grape juice. That sounds like fun, man. Okay, ready? So I got my bottle here, and I got my liquid in there, my food dye, and my salt. We're going to mix this up. Look at the salt just cascading in. It's like a cloud. This takes a bit. So while I'm shaking this, let's go ahead and stir this up over here on the left, our pH gradient. Let's see, if we get an equal amount of acid and base, that should turn green. But I think I probably have more base, which means it's going to be like a blue. Oh, no, look at that. I think the acid and base were perfectly mixed. Actually, there's a little more acid. That's a yellow color, which means we have pH 6. Interesting. All right, I don't know if that's working yet. No, I can still see there's a bunch of chunks here. Let me keep shaking. I got to keep shaking this till it... Come on, man, we got to... Oh, and it's a little bit cold. That's part of the problem. It works better if the water's warm because the salt dissolves a little more quickly in the warm water. Come on now. Shake, shake, shake. All right, what's going to happen? I hope it works. Let's see. See if it works. Is it working? It's totally working. It's totally working, baby. Come on now. It's totally working. So, look down there on the bottom. Hey, that looks blue. What the heck? I didn't add any blue. And then up there at the top, it kind of looks a little more pink. And in the middle, that's where the purple is. What the heck is going on? How did that change from a single violet colored solution to a tricolor blue, violet, pink solution? Isn't that cool? Blue. Isn't that cool? I think this will do better with just a little bit more color. So I'm going to go ahead and add just another drop of the purple food dye. Here we go. Let's add that drop just so we can see the colors a little bit better. Boop. And if you watch what it does, that's a clue. Look at how it just kind of stops right there. What the heck? Why is that? Why did the dye stop in the middle like that? Isn't that interesting? Well, of course, there's two different fluids in there. So at the beginning, I had a bottle like this. Yeah? And it had water in it. Okay? And then I said, hey, let me fill this up. But I didn't tell you what I was filling it up with. So when I filled this, I filled it with alcohol, isopropyl alcohol. I didn't tell you that, but that's what I did. So there was actually two different liquids in here. There was water and alcohol. Now, water and alcohol mix in all proportions. So when I added the alcohol, and then added the dye, everything just mixed up really well. All right, no issues going. Here, I'll show you. Let's talk about this so you get an idea how. I don't know if I have enough. We're gonna give it a shot. There, I'll show you the whole thing from the start. In case you're wondering how the heck did we get those three colors? Well, let me show you. I'm going to use acetone instead of alcohol for this, but it's the same kind of thing. It's the same idea, okay? You just got to give me a second because it's a little hard to open up this can of acetone, all right? All right, hold on. Got to get my scissors out so I can pop the lid. There we go. Okay, so I have this water here, and then I say, hey, I'm gonna fill this bottle completely. Now again, there's water in here. There's water in this bottle. And then when I say I'm gonna fill it up, I don't tell people what I'm filling it up with. So here we go. We're gonna fill this bottle all the way to the top. Now what I'm adding is acetone. So I'm adding acetone to water. You can kind of tell that those two liquids don't mix very well. You see, well, I don't want to say they don't mix very well because they actually mix very well, acetone and water. But you can tell they're not immediately mixing. All right? And that's because the acetone's less dense than the water, and so it's gonna rest on top of the water for the most part. You can see two layers. So here's your acetone layer. Down here's your water layer. And just so you can see it this time, I didn't do this last time, but just so you can see it this time, I'm now going to add the drop of food coloring. All right? That's not the way I did it last time. Last time I mixed it up first. So here we go. I'm going to add the drop of purple food coloring. And it goes. Whoop. Ha! And you can see the tendrils. You can see the tendrils. And it doesn't sink all the way because there's sort of a water-rich layer here on the bottom, and there's an acetone-rich layer on the top, and that food dye is not going to sink down much lower than where you see it. All right? Because there are two different layers. Now, however, if I take the bottle, which now contains water, acetone, and food dye, if I mix this up, you can see the two layers, yeah? Here, let me mix this up. Water and acetone mix in all proportions, and so when I do this, it all mixes together. The dye, the water, and the alcohol. It does look like that average. The dye, the water, and the alcohol, they mix in all, the acetone, they mix in all proportions. Now here's where the fun part comes. Here's where you get the separation. When you add the salt, which I'm going to do next, what happens is the salt and the water, molecularly speaking, like each other an enormous amount. And just like when two people love each other an enormous amount, they will sometimes date exclusively. The same thing happens when you add salt to water. What will happen is the water and the salt will mix together so well that that's all that wants to mix. They don't want to mix with anything else. And so what they'll do, the salt water will do, is it will push out the alcohol. The alcohol's attraction is not, well, it's acetone this time, but the acetone's attraction is not strong enough to overcome the attraction between the salt and the water. And so the acetone gets excluded. We call this salting out. We chemists call this salting out. So I'm going to just start shaking this, and this is where you're going to see that separation happen. Hello there, Andrew. And here, this is what's going to look like at the end. So you'll get your salt water layer and your alcohol or acetone layer. I got to keep shaking because I don't think I've got enough of the salt dissolved yet. Come on, baby. Come on, baby. Shake it up. Add potassium permanganate. Don't have any. Come on now. Get it all shaken up. Let's see if we got enough. Let's try. We'll see if it worked. Oh, yeah, it worked. So you can totally see now, up at the top, you can just start to see it at the bottom too. So this now is the acetone layer, and down here at the bottom is your saltwater layer. It's not quite working well enough. I think I got to get a little bit more salt dissolved. You get some weird layering if you don't get quite enough dissolved. Let me shake that baby. Shake, shake, shake. Come on now. Let's see if that works. See if I got enough dissolved. It's definitely working at the top. There it goes. You can see it at the bottom now. You totally see the blue color at the bottom. You see the salt water layer on the bottom. You see the alcohol layer, is the acetone layer on the top. And you see the mixture layer in the middle. So, and the reason why, let me get this guy shaking, the reason why you get the color separation is because the purple dye is actually made of two different colors, right? We know that purple dyes are made of a bluish dye and a reddish dye. And it turns out that the pink dye dissolves better in the acetone layer, whereas the blue dye dissolves better in the saltwater layer. And that's why you get the separation that you do. Now, this purple layer, that's actually a mixture of the salt water and the acetone. And it's a transient mixture. We call it an emulsion because it's a mixture of salt water and acetone that's not going to last forever, just like when you shake up your salad dressing. It doesn't stay mixed forever. It separates. But that transient mixture, we call that an emulsion, and both dyes dissolve in the emulsion. The salt that I add is just regular old sodium chloride. Very cool, huh? Very cool. Yep, I just added sodium chloride. So there, that's the chemistry of my mixing experiment. All right. So, what do y'all think? You having a good time with the chemistry here today? Let me know what you're thinking. We want to do some more experiments. We just want to talk for a little while. So long, very cools. Estrogen wants some more experiments. You got it, I am, Brad. Thanks, our average. Thanks, Amos. Yes, John Doe, it would work with potassium chloride. It works really well with potassium carbonate. More experiments. Why did the one on the left turn red? Let's talk about that, all right? Let's talk about the one on the left over here. Let's switch this around. So what we're doing over here with the one on the left, I don't have any bromine. Nice, Pang. So, thanks, Dave. So what I got over here in the flask on the left is it's just a flask. I don't have any of that egg. I'm not making any of that. And I'm not tasting them either. I don't want to ruin my afternoon. So this has an indicator dye in it called universal indicator. Universal indicator shows these colors at different pH values. So if I add acid to this flask, it's going to shift to these red, orange, and yellow colors. If I add base to the flask, it'll shift to the blue and violet colors. And if I perfectly balance the acid and the base, it'll turn green. So it's just like this. I do have some indium, Hans. What do you want me to do with indium? Yeah, let's go like 2 drops. Hans, what do you want me to do with some indium? Because I've got some. I've been saving it for trying to do an experiment. Look at that. Yeah, that's beautiful. It's getting all the colors as the reaction takes some time to go. Very cool, huh? Skylar wants me to get some plain water, add indicator, and blow into it. We can do that, Skylar. Here we go. Let's do it this way, Skylar. I'm going to go ahead and add a drop of base to this. So Skylar has asked for an experiment that we're going to try. Have I ever done electrolysis with water? Absolutely. Let me show you how you can do electrolysis with water too. This is what you're going to do. You're going to go to your tap. You're going to get a little bit of tap water. You're going to add a little bit of salt, and then you're going to stick a 9-volt battery in there. Voila! You're going to see bubbles form on the electrodes of the battery if you do this, and that's water electrolysis. It's that simple to do. All right, here we go. So I've got this at pH like 10, right? Very basic. Now I'm going to start transferring some of this over into this flask over here. It's going to take me just a little bit. And I'm going to exhale into this flask on the right. Now, when I exhale, obviously what I'll be exhaling is carbon dioxide. But something you should know about your exhaled breath, your exhaled breath is not 100% carbon dioxide. It's only like 4% carbon dioxide. Most of it is nitrogen, just like the air. So mostly what you inhale and exhale is air. However, the air that you exhale is a little lower in oxygen than regular air, and it's much higher in carbon dioxide than regular air. So exhaled breath has 16% oxygen, whereas the air has 21%, and exhaled breath has 4% carbon dioxide, where inhaled breath has very little. Okay, ready? So now what we're going to do is I'm going to exhale through a straw into this, and you're going to see what effect carbon dioxide has on the pH of our system. Here's your pH over here. Let's get some light on that so you can see it, so you can check out what's going on with the pH. And remember, if carbon dioxide's an acid, we should expect to see the pH drop. Here we go. Here we go, baby. Let's breathe in there and see what happens. I got to yellow. That's usually what I expect to see. So just by exhaling through a straw into the violet colored solution, we change the pH from pH 10 down to pH 6. So yeah, so it's carbon dioxide is an acid when it's dissolved in water. So soda's acidic, absolutely. Yeah, I have heard that. I have heard, Blackheart, that some Muslims say that, I guess Muhammad said not to blow in water. So I had never heard that before, but I did a video on it and I got that comment a lot. I'm not, I guess I could make some hydrogen gas. I don't know if I have, I don't think I have the stuff for it here. Yeah, I do some electromagnetism stuff. Oh, Jason, so you actually bubble carbon dioxide into pools to lower the pH. That's interesting. I had not heard of that before. That's very interesting. Combustion, Hans. Combustion is just a carbon-containing material, reacts with oxygen to produce carbon dioxide and water, and a lot of energy is released. That's combustion. Thank you there, Amos. The indicator signal is universal indicator. Interesting, Blackheart. Yes, that is kind of what happens if you hold your breath. See, we exhale because carbon dioxide it's acidic. And if too much carbon dioxide builds up in your blood, then the pH of your blood drops. And if the pH of your blood drops, you're in trouble. That's called acidosis. And so when you exercise, you not only need to inhale more because you need more oxygen to burn more glucose, but you also exhale more. It's a beautiful balance. You exhale more because you're building up carbon dioxide that needs to get released. And so as you need to inhale more, you need to exhale more because, yeah, carbon dioxide in your blood, you don't like that feeling. Interesting. Jason. Probably not, Skylar. Yes, it is home TV. So estrogen, the effects of acidic blood is death. You don't feel real good. It's called acidosis. It's a medical emergency. Thank you there, David. I don't have any, Hans. I don't know, Shane. Kitty, I've not, but I'm interested to hear more. That's right, Skylar. Blood usually its pH is like between 7.35 pH, 7.35 and 7.45. You got it, Skylar. Come on now. Thank you there, Rococo. That's right. Alkalosis is just as bad as acidosis. You don't want either. You don't want to be blood pH too high or too low. So long, Blackheart. That's cool. Very cool. It is home TV. Fastest way to counteract acidosis. What is the fastest way there, D? Thanks there, Pang. Oh, man. Well, I think we've had a good live today, folks. I'm running out of steam. I had a good time with you all today. Really had a good time. So thanks for hanging out, huh? Appreciate that, Mel. Thank you there, Crack. Thanks, Average Girl. Next live Pang is usually this time. So it's going to be either around here or maybe an hour, maybe a bit later. Somewhere in this neighborhood. Thanks, Estrogen. Great to have you around. Thanks, Last Dance. Thanks, Ergara. Depends how long you're measuring it, Hans. Thanks there, Shane. Thanks, D. Hey, man. Me too, D. Finish it off at pH 7. You got it. You got it. We're going to finish it off at pH 7. Yeah, you don't want to inhale dry ice. That's for sure. Here we go. I hit pH 7. We're done. Come on now. John Doe, you can find my email through my channel page. Home TV, we'll talk about that next time, all right? My wife just came home from work, and I want to hang out with her. I'm trying to get to pH 7. There we go. Yeah, Remy, look at the short I just put out yesterday. Not yesterday, it was a little while ago. There we go, pH 7. That's going to be a wrap. We're going to see you guys next week. Thanks for hanging out, doing some science experiments. I had a great time with you all. You guys make this a lot of fun. You really do. You make me look forward to this every week. So thanks for hanging out, and I will see you next week. So long, folks.